Good day. This is Carmel Sabadoborlat, your instructor in ES9, Advanced Engineering Mathematics. This is the second topic for our midterm, matrices, vectors, and determinants. Kumusta na mo? I hope everything is fine with you. Okay? So, our intended learning outcome at the end of this discussion are: first, you will know the basic concepts and rules of matrices. Basically, its definition, the types, and special matrix are discussed. Second, be able to solve addition, subtraction, multiplication, and division of matrices. So the basic operations of matrix will be discussed. The rules governing those operations, and of course, we will give you sample problems. And as we go through the sample problems, or please prepare already your notebook and ball pen so that while discussing, you will write down notes and you will solve on your own so that you can learn by listening and doing. Is that okay with you? So let's start. By the way, I will explain this topic as simple as possible so that you will understand matrices and determinants and other subtopics under this discussion easier. So let's start. Okay. Basic definition of a matrix is it is a set or group of numbers arranged in a square or rectangle array enclosed by two brackets. So basically, a matrix will look like this. This one, this 1 by 2 matrix, a 2 by 2. So there are advantages why we use matrix instead of just this normal normal linear equations. The first is it reduces the complicated systems of equations to simple expressions. So you arrange the group of equations accordingly, and with a matrix it will look simpler. Second is it is adaptable to a systematic method of mathematical treatment and well suited to computers. So basically, if you have a matrix, then you will input it in a software. Then if you will do it, if you have 10 by 10 matrix and if you will solve it, then it will take probably many hours. But if you have 10 equations, 10 unknowns, and put it in a computer and in a form of a matrix, then in a split of minutes or seconds, it can solve the problem. And you can have your 10 unknowns by that time. So with the matrix, your life will be easier. So one more thing. Please set your mind that this discussion is easy and everything will follow. Okay? So there are properties of a matrix. So we have 3 by 3 matrix, 3 rows, 1, 2, 3, and 3 columns. 1, 2, 3. That's a 3 by 3 matrix. We also have 2 by 4 matrix, 2 rows, 1 and 2, then 4 columns. 1, 2, 3, 4. And also we have 1 by 2. So this one is an example of a 1 by 2. So the properties of a matrix is a specified number of rows and a specified number of columns. So it should be specified in a matrix how many columns, how many rows. So the two numbers, rows and columns, describe the dimensions or the size of the matrix. Understood? Next slide. So a matrix is denoted by a bold capital A. this one. And the elements within the matrix are denoted by lowercase letters. And it is enclosed in a bracket, this one. So matrix A with elements I and J. So this is the element 1, 1. Element 1, 2. It only means that element A, 1, 1 is found in the first row and the first column, while element A2, 2 is found on the second row, 1, 2, and the second column, 1, 2. This is A2, 2. I goes from 1 to M, and J goes from 1 to N. Remember, your I, since this is since matrix A is with elements A, I, J, then I goes from 1 to M. Then J is represents the column goes from 1 to N. So, understood? Next. As I said, part of our intended learning outcome is for you to get to know the different types of matrices and be familiar with it. Okay? So the first type is a column matrix or a vector. So usually this is 3 by 1 are column. One column. So the number of rows may be any integer, but the number of columns is always 1. Again, a column matrix or a vector is having any integer for its rows, 1, 2, 3. So any 1 to m, any integer. You can have 1 to 10 for the rows, but the number of column is always 1. That is called a column matrix. A row matrix, it is any number of columns but only one row. So you have 1, 2, 3. We have 3 columns, 1 row. So 1 row, but how many columns? 1, 2, 3, 4. So it means that the columns A up to 1 up to N. A 1, 1 up to A 1 N. So you can only have 1 row but an integer column. The third type of matrix is a rectangular matrix. It contains more than one element and number of rows is not equal to the number of columns. It only means that your M is not equal to N. So, in this example, how many columns do we have? 1, 2. And how many rows? 1, 2, 3, 4. It means that we have a 4 by 2 matrix. How about this one? How many rows? 1, 2. And how many columns? 1, 2, 3, 4, 5. So we have a 2 by 5 matrix. The next type of a matrix is a square matrix. The number of rows is equal to the number of columns. It means that your M is equals to your N. So a square matrix has an order of M because basically your N is equals to M. So you have an M by M matrix. So in this case, you have a 2 by 2 matrix, and this one you have a 3 by 3 matrix. The principal or main diagonal of a square matrix is composed of all elements A, I, J, for which I is equals to J. The next type of matrix is a diagonal matrix. This is a square matrix where all the elements are 0 except those on the main diagonal. So a diagonal matrix has the elements equal to 0 for all elements except in the main diagonal. And this is the main diagonal of a matrix. And in this 3 by 3 matrix, we have this one. Okay? Next. A unit or identity matrix, and we can call it bold I or simply I. A diagonal matrix with ones on the main diagonal. So this is a unit matrix where the main diagonal is where the elements of the main diagonal is equal to 1. This one. Then we have the null or zero matrix. Simply all the elements are 0. Next is a triangular matrix. By the way, we have two types of triangular matrix, and we will discuss this with the examples. So the definition of a triangular matrix is that it is a square matrix whose elements above or below the main diagonal are all zeros. So we have an upper diagonal matrix, upper triangular matrix, and the lower triangular matrix. This one is a lower triangular matrix where the elements above the main diagonal, this one, are all 0. And this is also a lower triangular matrix. And this is an upper triangular matrix where the elements below the main diagonal of the matrix are all 0. It's discussed in this slides. So basically, it is a square matrix. We have this 4 by 4 matrix, and all the elements uh, below the main diagonal are 0. Okay? And the lower triangular matrix, all the elements above the main diagonal are 0. The scalar matrix. It is a diagonal matrix whose main diagonal elements are equal to the same scalar. So scalar is defined as a single number or constant. So when you have the values of the elements in your main diagonal are all constant, then you have a scalar matrix. Remember, it must be the same value. The values of the elements in the main diagonal must be equal, must be constant or a single number.